No, there was an ad. There was an ad for YouTube that just showed up.
What was that? Okay, so on your instruction sheet, when you are having a look at what it tells you to do for the discussion, there's only 3 points. It's a general opening statement. A discussion should be written which addresses critical issues such as, and there's only 3, any variable which could have changed and significantly affected the results, and what was that effect? Hashtag uncontrollable variables, that's what that means. Limitations of the theory's applicability, both in the practical situation and at the extreme limits of the independent variable. That's hashtag 0 and infinity. Like what happens when distance is 0, what happens when distance is infinity. And the last one, I don't really like this last one, but anyway, unexpected outcomes from processing of results and a suggestion of the cause and the effect on the validity of the conclusion. So I don't like it because in my head processing means like calculating the averages, calculating the uncertainties. It just doesn't make sense to me to ask for unexpected outcomes from calculating averages. But we're just going to go with it. I had a wee look at the exemplars online, and the thing that they seem to have gone to is systematic errors. So we're going to have a chat about
that. What does that mean?
Yeah, we're going to have a look at what that means. So, coming back to this first one, uncontrollable variables. And so think about our experiment. That was like we had a little light bulb and we moved the light sensor different distances away from the light bulb. What were the things that we did control and we could control in that? What do we control?
The brightness of the bulb.
The brightness of the bulb, like we had the same bulb and we kept the same voltage so that the brightness of the bulb was always the same. What else?
Maybe the ambient light.
The ambient light we more or less controlled by closing the curtains. So thinking about that, following down that same pathway, uncontrollable variables, we're trying to think of things that we would love to have been able to control, but we just couldn't quite.
Background light.
So maybe background light, you could argue background light, the curtains were flattening and so you had like a varying amount of background light coming in. What effect might that have had on your conclusion?
Well, it could have made some of the results higher or lower than they should be.
Oh yeah.
But that's why we repeat an average.
That's
right?
why we repeat an average. So you can make a good argument that goes along those lines. Like, okay, so the curtains were flattening and so our background light was going up and down, but we measured it 3 times and calculated an average. We got rid of that and we did the 0 error. Because we repeated an average, we don't think there's going to be any impact on the validity of the conclusion because it's going to be a random error. Sometimes the light's going to be higher, sometimes it's going to be lower, but that randomness of it should mean that repeating and averaging kind of deals with it. So that's one thing. Anyone else got other variables that they might have really loved to be able to control but they couldn't?
Holding the light thing at the same height, or like directly in line.
And the same angle, eh? Yeah, good. So what effect might that have had?
Big.
Like what?
Same as before, just like different numbers, higher or lower measurements.
Oh yeah. And so would it have had a random effect that might have been dealt with by repeating and averaging or not?
Probably not. If you did it the same every time, but it was like not a perfect angle.
How might you know it's at the perfect angle?
Perpendicular to it.
Yeah. What might you see on the reading that
The
will tell you?
highest brightness.
The highest reading. If it's pointing exactly at it, you're going to get the highest reading, and if it's like too high or too low or pointing off to the side, it's going to be lower. So you can.
The reason why the repeating averaging might not work is that you might do it all 3 times for that one distance and then change it for the next distance.
Right. And you might have it always pointing down at the floor a little bit or something.
Yeah, for all 3 of the ones the same distance, and then you do the next distance and you do it perfectly. The repeating averaging wouldn't do it.
Okay, so e.g. the things we come up with were thinking about this probe one, they're not going to be random though, because they're never going to be too high. It's not like the curtains that sometimes blow out and sometimes blow closed, so sometimes the light goes too high, sometimes the light goes too low. With the probe, it's always going to be a bit lower because you're never going to be pointing it perfectly in the right direction. It's never going to be perfectly at the right height. It's always going to be a bit off. And so our results are always going to be artificially a tiny bit lower, aren't they? What effect might that have on the validity of our conclusion?
Well, surely that's negligible.
Well, if they're all slightly lower, then would it change the relationship?
Nah.
Because
They're
you're
not
slightly lower in
proportional.
different amounts though.
Yeah, they're not proportionally.
Like if they're
But-
all slightly lower, but like the same amount, that would, you could like count that as like 0.
Yeah.
Yeah, but surely like that tiny little number isn't as
Yeah, but
as
it might-
negligible.
Might be a tiny number for that one and a huge one for the next one and a huge one and a tiny like.
You know, wouldn't like this is all stuff that won't change the
But
results
surely there's a-
drastically, because we would have had all these problems, but we still got an answer.
Well,
yeah.
that's great. It's not
Because-
perfect.
Because surely
That's
surely a
not-
functioning human can hold it at pretty much parallel.
Functioning. Opposed to
Like pretty
non-functioning.
pretty close that it would be negligible, surely.
What?
No, you'd still be like
You could, like,
vary
hold it like
by
that.
5 degrees easily.
But yeah, but how much-
Affect the closer and right.
How much light does 5 degrees really change?
So you can have a play
If you're
around
fast,
with it.
Like 3 meters away, you know, it's not really that much of a difference.
Yeah.
You know, 3 meters and 4 meters isn't that much.
If you're like 10 meters away, then like 5 degrees is going to be like completely off.
No, like 10 centimeters away.
As you're doing your experiment and you think of these things, like it's okay to come back and test it. Like you could say, oh, I really want to know like what happens, and like deliberately put the probe like 5 degrees off or whatever and see like what effect does it have. Is it negligible or is it making a like a noticeable impact? So you might like think about this and kind of mull it over for a few days and then come back and have another crack and see like does it make a difference, and you might provide evidence that yeah, it's negligible. I came back and tried it. I thought the maximum I could be off is 5 or 10 degrees and it didn't make a significant impact. Or maybe it does. I don't see, argue it out. But those are the kind of things you might be looking for that. Next one, limitations of the theory's applicability, both in the practical situation and at extreme limits of the independent. So we're thinking about what happens down at 0, what happens at infinity. Who can go through one of those for us? Where do you go?
Oh, it's just like the light fades to background light at like certain distance.
Oh yeah. So can you get to infinity?
No.
No.
So way before infinity.
Way before.
But where is infinity?
Oh, it's quite a way.
Okay, yeah.
Infinity.
How many?
Yeah, like 10 meters. That's pretty far before infinity, right?
Second infinity.
But how far before?
Quite-
Yeah, so you make an argument that like once your measurement gets to the background light, like you can't make a measurement that's meaningful. You've kind of got to a negligible, unmeasurable impact relative to the background. So you can definitely make that argument there. It's like the more detail that you would kind of go into, you might nudge that up to excellence level. What about 0?
Is it like the maximum?
Overload.
Who got something weird happening on their graph? A little bit of a curve
Is that-
off.
Does it change from like a point light source to
The
a
blob.
different one when you put
Yeah.
it?
Boom. So a point light source, as you move away from a point source of anything, the strength of the field due to that thing falls off. They call it an inverse square relationship. So it's like 1 over the distance squared. That's why we're expecting a gradient of -2, power of -2, like divided by distance squared. That's what like gravity does around a planet. It's what light does around a light bulb, a single light bulb.
Are you saying that gravity's point source?
If you're a long way away from a planet looks like a dot, so it counts as the point source. It's just relative, it's the relative dimensions. And so bringing that same idea of relative dimensions back to the light bulb. When we look at the light bulb, it's got that like curly little filament inside the bulb, right? And the light's like coming out of that curly filament. That's the actual light source. And if you get really close to that, that thing's like a centimetre long. And if you get within a centimetre of it, that's not a point of light. It's like a kind of bar or blob of light. And so the problem that you might find here, and you probably see it on your graph, you probably see on your graph the evidence of it, that you get a beautiful straight line of x's, but as you get close to some really small distances, your light is a little bit higher than what you expect.
Yeah.
So your x's might do that, and so when you fit your best fit line, you might be like, oh yeah, actually, I'm just going to fit to those points there. I'm going to add a set of data that doesn't include those 2 points, because that's the point at which my light bulb is no longer a point source, it's a blob source. And but you might say that your error line does account for those, maybe, something like that. Recognising the point source versus a blob source, and think just taking a moment to step back and think about technology and engineering and stuff. That's why in the supermarket and in classrooms they have lines of light, because the intensity of light from a line of light it's not an inverse square law, it's just inverse. So 1 over the distance. And if you go to really big flash auditoriums, they've got those big square panels of light, like a big plane source. The intensity of light, if you've got a whole big plane, stays constant. So depending on what your how big your space is, what your light engineering looks like, you might choose a different geometry of your light source to best produce the light that you need in that space. So that's kind of cool. Systematic error. Systematic error compared to random error. Systematic error is when the error is always on one side and not on the other. So this probe angle thing is a good example of a systematic error. This error is meaning that our light measurements are going to constantly be a little bit smaller than what they really should be. A classic example of a systematic error might be if you're doing a chemistry experiment, you've got a bit of magnesium and some sulfuric acid, and you're looking at how does the rate of reaction depend on the concentration of the acid. Well, the problem with that is that the reaction itself produces heat, and the heat is a systematic error. It's always going to increase the speed of the reaction. So systematic errors are errors that you can't deal with by repeating and averaging. So generally, systematic errors, things to look for are heating. If your experiment's got a source of heat, by doing your experiment it generates heat and that changes the conditions. So friction. So often systematic errors look for heating due to friction that might produce a systematic error, and think about what the result of that might be on your experiment. So that's it. The systematic error is an error that's always on one side, always on the other. If I was hunting for one, I would hunt for heating due to friction.